Hi there. We just finished simplifying the two traits, iterable and iterator, into one type that only has arrows. And the reason we did that is that we wanted to use our magic dualization trick to reverse the arrows. And that requires us to have a type that is just expressed in terms of arrows. So here's our type iterable. It's a factory of factories of values, where the values can either be a single value or nothing, or the whole creation of the value might fail. And I love this type. I mean, this type, there's no noise of traits or anything. It's just the essence of what an iterable is. It's a factory of factories, and that's also beautiful by itself. But we're not going to talk about iterables anymore. We're going to talk about the dual of iterables, namely a push-based type, where we can get sequences of values in an asynchronous way. Because here you see that here you can see the synchrony, right? I have a function from unit to try of t, and that function is going to block until the next value arrives. So let's turn the arrows around, flip the arrows around, and there we go. We just flip the arrows around. And what we're going to do now is we're going to do the dual of simplification, which is complexification. So we're going to take this type here, and we're going to complexify it. I'm not going to try to understand what it means right now. The first thing I'm going to do is I'm going to complexify this type. And complexify means that just when we removed traits and turned them into functions, we're going to now turn functions back into traits. All right, so that's what I mean by complexification. So the first thing is to give this guy a name, and let's call this type observable of t. So observable of t is a setter of a setter, like this. Okay, now the first thing we're going to do is now look at what part of this we can turn into its own thing. And the first thing we're going to do here is to look at this ugly trie of option of t. And you know, as I said, it requires pattern matching and all the complexity. And in the end, when you look at a function that does pattern matching on a value of trie of option of t, it will have three cases. The trie case, so that's you get a throwable. If it's not a throwable, then there's two cases, when there's nothing or where there's just a value. All right? So when we pattern match over a function that has an argument trie of option of t, really we get three cases, and those are the functions. So we just split this into these three functions. So instead of trie option of t to unit, we get three functions. Now we see three functions. So what are we going to do with that? Well, we're going to put those into its own type and then substitute it in there. So what is an observable now? It's a function from observer to unit, and an observer is a triple of functions. Good. So now we have split the world there, and now we're going to continue to complexify, because instead of having a triple of functions, we're going to put those in a trait, and then what we're going to do at the same time is we're going to turn these functions into definitions. All right, so this triple of three functions becomes one trait with three methods: on error, on completed, and on next, and nothing here changes, right? So the observable still takes an observer to unit. But I just want to leave this here to remind you that these three functions are now represented by that single trait. Okay, continue complexification. What we're going to do now is we're going to turn this observable into a trait as well by introducing a method, and let's call that method subscribe, and that then takes an observer and returns unit. Okay, so all we have done is we have kind of split this complicated trie of option of t arrow unit into this trait, and then we have introduced a trait for observable as well that takes an observer. It's all straightforward. These things are all equal. So here is our type after dualization. And now it's time to interpret what this means. Well, an observable is something that I can feed a callback, and that callback consists of three functions. What happens when there's a regular value? And the difference with futures is that this callback can be called many times, 0 or more, and then, so it represents a stream, and then the stream can either complete normally or complete with an error. All right? So really, it's a little bit like in Java where you have button, and a button has different callbacks for clicks and mouse over and whatever. So the same here. There's an observable that takes a trait that has callbacks for various different events that can happen. Delivery of a value, the end of a stream, or an exception. Now, the truth is a little bit more complicated, because just like with a button, where you have an event, you add an event handler, a callback, you might want to remove the callback. All right? And what we do here is we have that when you subscribe to an observable with an observer, what you get back is a subscription, and a subscription is this trait that allows you to unsubscribe, which means remove this observer from this observable. And when you know JavaScript or any language that uses events or callbacks like C#, or as I said, JavaScript, you have the same mechanism. You can add an event handler, and then you can remove it. And in this case, the way we remove it is by returning a special object with a method to remove it, and then you have a Boolean here as well that you can check whether the callback has been removed. All right, so let's put them side by side. And now you see here observable. It has this notion of subscription. The onNext, onError, and onCompleted are really kind of encoding of these two methods plus the fact that this can throw. And then you see here that the iterable and the iterable and observable are similar, except that one returns an iterator and the other one takes an observer. Now, in .NET and in other languages, the iterators also have a notion of subscription. Because if you're iterating over a collection, the consumer might want to tell the producer, I'm not interested in any more values. And in that case, it's handy that the iterable iterator traits also have a notion of subscription. But in Scala and in Java, that's not the case. But if you look in Dart or C#, there it is the case. All right, so now we have seen all four effects. We started out with trie of t to make clear that a computation could fail. Then we moved on to futures, which is a monad, an effect that tells you that a computation takes time and can fail. We showed that these two were connected via dualization. Then we looked at synchronous collections, so collections of values where you pull, where you block, just like, and you have a function here that you block. And then we used the same dualization trick to go from here to here. All right, thank you so much. Now we know how all these four effects are deeply connected via the magic of category theory. Thank you so much, and see you next time.